All right. Hi, everyone. Thank you for attending this session and this talk. I'm Anandghan, and I'm super excited to tell you about GlucoScreen. But before we begin, I want to quickly explain the difference between diabetes and prediabetes. So diabetes is a condition where a person has elevated blood glucose, which are way beyond normal. On the other hand, prediabetes is a condition when the blood glucose levels are higher than normal, but not as high to be diagnosed as diabetes. And this paper mainly focuses on addressing the challenges of prediabetes. In the US, approximately 96 million people have prediabetes. That's more than 1 in 3 adults. And the worrying part is that 80% of them don't even know that they have prediabetes. So there exists this gap between the risk of getting diabetes for at-risk people and them knowing it. The bad thing about prediabetes is that it can lead to full-blown diabetes if preventive measures are not taken. But the good thing is prediabetes is reversible if healthy diet and lifestyle changes are made. So our goal in this project is to reduce the barrier to glucose testing and make it more accessible. Current screening techniques for blood glucose includes going to a hospital and doing a test in laboratory, which is expensive and sometimes not even available, especially in developing areas and countries. Over-the-counter testing is less expensive than lab testing, but still not economical just for the purposes of preventive screening. Our solution to address the challenge of pre-diabetes screening is GlucoScreen, a low-cost, readerless glucose testing strip that works with any smartphone and allows testing from the comfort of your home. Here's a quick video overview of how to use GlucoScreen. So to use the GlucoScreen strip, first you attach it to the phone on the back side so that it's aligned with the phone's flash. Then you flip the phone, connect it to the front, and then while doing the actual test, you do a tiny finger prick, take a small drop of blood, apply it to the phone, and then the phone collects the data from the strip for a few seconds, processes it, analyzes it, and then shows you your blood glucose level. So to achieve this goal of low-cost glucose testing, we did several things. The first one was we removed the requirement of a dedicated reader, which by using the ubiquitous smartphone for the computation and display, which reduces cost. Second, we added minimal components to the strip such that the strip could directly interact with the phone. Third, and the most significant contribution, is that we developed a communication for the strip to interact with the phone through its touch screen, which proved to be very cost and energy efficient. And finally, we designed the overall circuitry to be very, very low power, such that the whole strip can work from the energy harvested from the phone's flash. So while contemplating the design for GlucoScreen, we explored multiple communication methods like Wi-Fi, Bluetooth, USB, NFC, audio-based techniques, and a few more. But none of these were like cost and energy efficient. And that's why we developed the capacitive screen technique, which proved to be very effective. So the data transfer via touchscreen happens by the strip imitating touch events on the phone electronically, and the data is encoded in the timing of these touch events. We used pulse width modulation technique to encode the data, which is a straightforward method of encoding and also for hardware design. After we built a prototype, we validated it in vitro and clinical studies. Our primary objective in the in vitro study was to evaluate whether GlucoScreen can work with different glucose concentrations and can it work across different phones. And to achieve this, we tested on 5 different phones, including Android and iPhone devices. Additionally, we also compared GlucoScreen's accuracy with 2 commercially available glucometers. And first, to see how GlucoScreen works with different concentrations, we did this leave one concentration out cross-validation and used a linear regression model. And the findings suggested that GlucoScreen's accuracy is comparable to commercial glucometers. The detailed results can be found in the paper. And similarly, to see how GlucoScreen functions across various phones, we conducted a leave one phone out cross-validation, and the results also indicated that GlucoScreen can consistently operate across different phones. In our IRB-approved clinical study, we enrolled 75 participants from whom we gathered 85 samples. And the aim was to evaluate to see how GlucoScreen works with real blood samples. And the results from clinical study also showed that GlucoScreen has a higher accuracy and comparable accuracy to the off-the-shelf glucometers. And these results and all the details of the studies are available in the paper. So overall, the results suggest that GlucoScreen can enable large-scale, rapid diagnostics for prediabetes. But as we look further, this technology holds the potential to screen for other diseases as well. And our high-level goal here is to enhance rapid diagnostic tests, similar to those you've seen for COVID, by leveraging the smartphone's computing and sensing capability via platforms like GlucoScreen to improve the accuracy and ease of use of these RDTs. This concludes my presentation, but before we go to Q&A, I'd like to show you how GlucoScreen works via a live demo. And this demo will essentially involve me doing a tiny finger prick, take a tiny drop of blood, use the GlucoScreen strip to measure my blood glucose level. And if anyone is uncomfortable seeing blood, just look away for the next 2 minutes. And as you know, live demos always work, so no worries. There we go. Okay. So this is how the strip is right now. The first step is obviously open the app. So we have this app. It gives you an option to watch a tutorial, perform a test. So let's go to perform test. Now then ask you to stick the strip, which I've already done, hit next. Put the phone flat on the surface, hit next. And then this is where it asks you to draw blood. I'm going to do a quick finger prick here. So always sanitize the site. Look away if you're not comfortable. This is not what you expect while you do that, is it? Like this. So, you want to do a finger prick? Did it work? No. Let me try that again. Harder. I've done this so many times yesterday. Oh, there we go. There we go. So I'm going to hit begin test, and then I will apply the blood at 5 seconds, where it beeps. There we go. Done. There we go. Yeah. All right. Looks like I can use some cookies. All right, I'll like to take, thank you everyone. I'd like to take questions, and meanwhile, I'll sanitize this site for the next speaker.
Hello. Very nice presentation. Just a quick question. So the device that you showed, do you need to buy a new one each time you use it, or do you just need to change the needle out?
Right, so that's a very good question. So I think our original motivation is that this will be a disposable strip, because you're going to use this maybe just once a year. But in case if you decide to want it to be reusable, that's also an option. Just like the prototype I have, I can change the strip. So it depends on the use case, how do you want to use it.
Okay, so I think the major cost saving you're achieving is versus, say, the AccuChek that you showed. Your strip, so the AccuChek, once you buy, it's almost like a lifetime purchase, right? Once they buy it, they can use it multiple times, as long as they, excuse me, buy the testing strips. Is it somewhat similar in your case?
Yeah. So I think for AccuChek, it makes sense to buy if you know you already have diabetes and have to test on an everyday basis. But just for preventive screening, buying an AccuChek device is much expensive. And in that part where you're just trying to do preventive testing, buying a GlucoScreen strip makes more sense. It's more economical.
Okay, thank you.